Hello and welcome to linear equations. A cool way to visualize linear equations is with a seesaw. So with any seesaw, it's all about balance, right? And if I were to add a box on this side, the seesaw would slant to the right and the box would fall off. And then all of a sudden, if I add a box on the left-hand side, the only way the seesaw would balance like the picture is if the left-hand side box and the right-hand side box had the exact same weight. Now, all of a sudden, I add a box to the left-hand side. What's going to happen? Well, the seesaw is going to slant to the left, the boxes are going to fall off, and, it's no longer balanced. But if I were to add another box to the right-hand side, and now all of a sudden the sum of the boxes on both the left-hand side is equal to the sum of the boxes on the right-hand side, well then our seesaw is balanced. And with looking at equations, we know that it kind of follows a similar idea. Let me show you. Now, if we just said 10 is equal to 10, okay, the weight on the left-hand side is equal to the weight on the right-hand side. But all of a sudden, hey, I want a plus 5 on the left-hand side. So 10 plus 5. Now, that does not equal to 10. In fact, that equals 15. And so in order to make it balance, I have to say it equals to 10 plus 5 on the right-hand side. And what do you notice? Well, I plus 5 onto the left-hand side, plus 5 onto the right-hand side from our original equation. And yes, that equation is very simple, but it is an equation. So let's now test it when we have variables. And this kind of gets a little bit fun because a variable now is x. It is a, it is z, it is anything. It holds any value. It is a box. The size of the box can be big, it can be huge, but it holds a weight. And that is a variable. So if I said 5 plus x is equal to 10. What is x? Right, now using this principle, we can actually solve for x. Now, a cool important rule to get into your head is saying that the x should always be on the left-hand side and a value should always be on the right-hand side, meaning that we should always have x alone on the left-hand side and something that it is equal to. So let me show you what I mean. Now, if we had this equation, what would I do? Well, in order to get left alone on the left-hand side, x alone on the left-hand side, I would have to minus 5. But I can't just do that on the left-hand side and leave the right-hand side as 10. As we know, the left-hand side would now be much lighter, and therefore the seesaw would slant to the right and all the boxes would fall off. So it doesn't balance. So what do I have to do? Well, I have to minus 5 on both sides. Let me show you what I mean. So 5 minus 5 plus 10 is equal to 10 minus 5. I'm minusing 5 on both sides. And we know 5 minus 5 is equal to 0, and we're left with this x. And therefore, x is equal to 5. And if I were to put that into the equation, we know that would thus work out, right? 5 plus 5 is equal to 10. So it's perfect. So let's go into another example. And here we're going to introduce multiplication and division. And it's a little bit more complicated, but it's still just as fun. So if I said all of a sudden that 7x is equal to 14, now what do I do? So as I said, this rule, we're going to want x on the left-hand side alone, and it should equal to something. Well, in order to do that, what are we going to do? Well, I'm going to times the left-hand side by 1 over 7, or otherwise divide by 7, in order to get x alone. Let me show you what I mean. So 7x multiplied by 1 over 7. And in order for this to balance, what do I have to do? Yeah, I have to do it to the right-hand side as well in order for it to balance, like our seesaw. So what do you get? You get x is equal to, well, 7 times 1 over 7, oh sorry, 14 times 1 over 7 is 2. So x is equal to 2. And as we've said, we want x on the left-hand side equal to a value because x is just this variable. And so technically we're saying the box is, the box of x is equal to 2. And we're multiplying that by 7. Perfect, 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 perfect. Now we can go on to another example. And this one you can try by yourself and then watch the video afterwards. But let's try it. So if I said 7x minus 6x plus 5x is equal to 10 plus 2. So it's a bit longer, but it's still quite simple. So now because here our x's all have the same exponent, right? So these here all have an exponent of 1. We can add them up together. So 7x minus 6x plus 5x. So 7 minus 6 plus 5, what is that? That is, that's 6, right? So 6x is equal to now 12. And then it's exactly like every other example that we've had so far. And so now we have to do something to the one side in order for x to be alone. And what are we going to do? Well, we can divide 6. So we can say 6x divided by 6 is equal to, well, we know it's equal to 12, but we can't just have 12. We want our boxes to be the same weight. We want it to balance. What are we going to do? We're going to divide the right-hand side by 6 as well. Awesome. And what do we get? Well, we get x is equal to 2. And then we can actually test it, which is what this example is quite good at showing, is that we can test our variable and to see if it's right. So 7 times 2 minus 6 times 2 plus 5 times 2, because that is effectively what we're doing, right? So 7 times 2 is 14 minus 12 plus 10. Well, that is then equal to 2 plus 10, which is equal to 12, which is equal to our right-hand side. Perfect. Absolutely amazing. It works out. So we've proven that x is equal to 2. So now we're going to do one final example with fractions, which may be a little bit more complicated, but let's just see how it goes. So if I had 7 over 6x is equal to 12, what is x? Now you can try it on your own and then come back. So what are we going to do? Well, with this idea of balance, what we do to the one side, we want to do to the other side. I want x alone on the left-hand side. Well, we can start by timesing both sides by 6. And what's that going to do for us? So if I times the left-hand side by 6 and times the right-hand side by 6, giving us this balance, we say that this 6 cancels out with this 6, and we left over with 7x is equal to, well, 12 times 6 is equal to 72. And then we left with this. What is now x? So x is now equal to something. So we want x alone on the left-hand side. And again, we've got it back into this kind of simple formula. And so x is thus equal to 72 over 7. Why? Well, because we times this side by 1 over 7 and times this side by 1 over 7. Or otherwise, we divide both sides by 7. And we thus get this answer. And now you might be saying, well, let's test if that's true. Well, let's see. So we said that x was equal to 72 over 7. So 7 over 6 times by, now what is our variable? Our variables were x, and we said x was equal to 72 over 7. And what is this now equal to? Well, this 7 cancels out with this 7, and we then get that equals to 72 divided by 6. So 72 divided by 6. And what is that equal to? Well, that there is equal to 12. And so we've proven that there is equal to the right-hand side. We've proven that the boxes have the same weight, and we've proven the equation. Thank you so much. I hope you understand everything. Have a good day.